Hi, I'm Mr. Franklin, and this is Thursday, 8/27 class. I am recording our live session because I will not be in class on Thursday. I will be doing some stuff for my family. So, with that said, though, I don't want you to miss out on doing this lab. I want to be able to also help you out and do that. So, let's jump into it. Let's get going. So today's overall objective is to understand lab simulations and assignments, practice your vocabulary from this week, and experiment with the pendulum. The cool thing about an experiment with the pendulum is you probably know what a pendulum is. You just may have never heard it called that. But there are going to be some things that result out of our experiment that are going to surprise you. And that's almost a guarantee because it surprised me when I first did it. So I know it'll surprise you as well. So before we do that, though, I want to just recap as quickly as I can, just a couple of things from this week, give a brief preview of the quiz tomorrow, your reflection, and what I'm going to do about releasing Monday's homework early. So in the Pear Deck, there will be a student-paced Pear Deck that you can, mainly it will have questions for you to type in as we go. So you can type in here, you can pause the video, but type in things that you're struggling with or questions that you're having so far. So pause the video because I'm going to keep going, but pause the video, write what you think, and then unpause the video and continue. Okay, welcome back. Let's continue on. I want to talk real quickly. There has been one popular question about the textbook time. I've been getting a lot of emails about it. And then I will point out something on the identifying evidence. So let's jump over there real quick. In Canvas, go to modules and textbook time. So for textbook time, there's excerpt, which is not the same as accept. So please make sure that you do watch the video at the bottom of this one. And I actually only thought of this statement. I had forgotten about the second one that says, do not watch this video yet. I believe you can answer these three questions without watching that second video. I think they're all answered in the very first video, but you are more than welcome to watch the Explore More video and to help you answer those questions. Okay, so that was really the big question. Do we have to watch the video? The first one's really cool. Has astronaut Chris Hadfield showing some stuff with water. And then the second one is Bozeman Science, showing just some general ideas on science and the scientific method. Okay. But please let me know if you have any more questions on that. This one I haven't gotten very many questions on, so I hope it's straightforward. Make sure you're typing in the green box. However, this question and this question are the same question. So you only have to answer one. But if you do answer both of them, I hope your answer is the same because they are the same question. Okay? Alrighty. And that covers the assignments from before. Tomorrow, you will be taking a quiz. It's our first quiz. It is in the test and quiz grade category, which is 45% of your overall grade. And I know I just sent your blood pressure through the roof for some of you, but relax. It's only going to be 20 points. That's a really small quiz, okay? The goal of this quiz is, one, to help you practice and know what to expect on future quizzes. Two is to practice vocabulary and work through that. But three is to see what a quiz looks like, because there's going to be some questions on here that are going to look strange and different from maybe what you're used to. Maybe not, but I think it will be. So part of it is to practice using the quiz function in Canvas. So with that said, this is the one quiz where you're going to get 3 chances. You're going to get 3 attempts. Okay? There is no time limit. So if you go through and you make a mistake and you got a 90%, I would go ahead and go through it again and get my 100%. There's no reason you should not get 100% on this quiz, okay? What is going to be on the quiz? Half of the quiz, 10 points of it, is going to be vocabulary. All the vocabulary words, also the prefixes, centi, kilo, milli, okay? There's going to be a couple questions about independent variable, dependent variable from the experimental design video notes. There's going to be a specific question about the late work policy and a question about office hours / cave. There's also going to be one question about take care of yourself, take care of each other, take care of this place, which we had in one of our class sessions. And these two things are actually in the syllabus. So you can go and look there and get some of that information. So there you go. If you have questions, please let me know what those might be. Okay, real quickly, reminder, turning stuff in. There are 2 ways to turn things in if Canvas is not working. Canvas has about 3 different places for submit buttons. Please try to find those and submit them as best you can. But if it is not working, I do not want you spending 3 hours trying to figure out where the submit button is. I just want you to turn in the assignment, okay? So to do that for me, first option is go to your Gmail, send me an email, or share it through the application. So like in Google, up here where the share button is, you click the share button and share it with me, okay? The second option is go to Canvas, go to the inbox, click new message, pick the course, the physics, so it'll come to me, and then you're going to attach the pictures, the document. There's a place where you can attach Google Drive things. Just click attach and send it to me. Now, I may not grade it right away because I'm going to grade the Canvas stuff first, but I will get to it. Okay, so if you can't get it in Canvas, send it to me so that I have it. But I do not want you spending hours trying to figure out how to get it submitted when you can just send me a message and send it that way. I do want you to learn where it is in Canvas eventually, but sometimes that's just stressful. Canvas isn't working, whatever. Okay, with that said, Canvas gives a big red late symbol, even though the assignment is not technically late yet. Why is that? I try to schedule the assignments by the date I want you to work on them. So if you don't turn it in on that date, it'll say late. But the late policy is you have 1 week after that date to get it turned in for full credit. So your vocabulary assignment was due on Monday. If you don't have it done until next Monday, it's still not late until after next Monday. So Tuesday morning rolls around and you still haven't turned it in, then okay, now it's late. Now, if you've emailed me and we've been talking about problems you're having, that's a different story. I can work with you on that. But you have 1 week to get stuff turned in. So those of you that are procrastinators like me, please don't take advantage of that, but use that when technology isn't working for you. That's what it's there for, okay? What I would do is I'm trying to work on it. It's not working. Technology, my computer died or whatever. Mr. Franklin, it's not working, and I'll get it to you tomorrow. Just try to get it to me as soon as you can, okay? So I can't stress this enough, and so that's why we're talking about it again. All righty. Office hours, contact me by email. Once I get an email from you saying you want tutoring, it can be the same. It can be 5 minutes before 1 o'clock. I don't care. You send me that email and I will post a link in Zoom in Canvas, and you can just go into the Zoom link in Canvas. So, in Canvas, we have our little Zoom menu option here. You just click there and join the meeting there. But there will not always be one, because it's only going to be there if you've emailed me and said, hey, I want to meet. But that's where I'm going to post it. Okay. And you can schedule ahead of time. You say, hey, Mr. Franklin, on Wednesday, I don't have anything at 1 o'clock. Can I schedule something? And I will be there for you. Okay. Now, my time is limited, 1 to 2:15 p.m. So that's not a very big window. So if you need more help outside of those hours, use Miss Cook. She's the tutor assigned to me. But there are other physics tutors who they work with all the physics teachers, and we're all doing the same thing or pretty close to it. They know what's going on and they can help you. They're a huge help. So if you're stuck and need help, maybe even just need someone to verify that what you're doing is right, and it might take 5 minutes, it might take 30 minutes. Don't worry about it. Go to this link, go to their calendar, schedule it with them, get some help, okay? You've got tons of help coming at you, so take advantage of it. There's no excuse to not have help. Okay. So today we're going to finish lab. Tomorrow you're going to take a quiz. After the quiz, you're going to reflect on this entire week. What worked, what didn't work, what's going well, and then you're going to tell me what your quiz score is, and you're going to tell me how you're going to get help for those of you that are going to need to get help. Okay. On Monday, so that you don't get overwhelmed with a bunch of stuff just showing up suddenly on Monday, I'm going to post Monday's work on Friday evening. I'm going to try to post it on Friday evening and maybe even earlier than that, so you can at least get a start. The one thing not on this list I will not post is the weekly overview for the week. That will come on Monday, maybe Sunday night. But next week on Monday, you're going to do another What Do You Think via Pear Deck, and it's going to be about measurement. Then you're going to have vocabulary practice. You're not going to have to make new cards or anything like that. It's going to be the same words. You're just going to have to practice them. Okay, it's going to give you more time to practice them. Specifically, dedicated time to practice them. I will probably post for that assignment a video that maybe works through some memory tricks that I use to remember these words. Some of those tricks are in the pictures video within the assignment, but I'm probably going to do a supplemental video, like a 5-minute video going through all the words and maybe having even some silly and fun ways to remember them. And then there will also be some video notes. It will be on the topic of measurement. One of the videos is ready, and then there's a second one. There's going to be 2 videos probably, and there's the second one that I'm working on. So that's the week at a glance. All right. How are we feeling? Are we good for what's coming tomorrow and Monday? Go ahead and let me know. The Pear Deck may actually look different. It may actually have you type in the words, but you can also drag the blue dot to where you need to. Pause the video if you need to make that happen. And when you're done, you can unpause the video. Now I'm waiting for those of you that didn't pause it. Okay, all right, moving on. So first thing we need to do is we need to set up our workspace so that we can work. So let me start over here for you so you can see how I did it. So first thing we're going to do is you go into dashboard, and so you go to your class and go to modules, and then you're going to go down to the 1.5 Pendulum Lab. Click on that, and you will have this screen, and then you will also have the Google Doc at the bottom. First thing I want you to do is right click or control click on that and open the link in a new tab. So you want to open the document in a new tab, and then you're going to pull it down and separate the 2 tabs. And then you're going to, you may have to minimize it, but you're going to resize both windows so that they're side by side. So we're going to have the interactive lab over here on the left or on the right. You can do it whichever way you want. And then we're going to have our lab document over here. So I'm going to go here, and I'm going to go here. Now the other option, and the goal of doing it this way, is to help save you some time. So I may actually do it this way. I may blow it up a little bit so I can actually read it. Oh, you can also go up here to the hamburger and minimize the hamburger, and that'll also give you some more screen space. Okay. So the Pendulum Lab. Here are key definitions that we've been talking about in our vocabulary words. So you can read through those. A hypothesis is a proposed explanation. Okay. So it's a statement that answers a question. It requires investigation because it's a claim towards something that we're investigating. And it may or may not be true. And that's so hard sometimes in our current media-driven world, especially with social media, is sorting through claims that may or may not be true. And so we're going to make claims that may or may not be true. Then we're going to collect some data and then look at this as evidence. Does this statement of fact support our hypothesis? And we're going to analyze that. So there's generally two parts for an analysis of this stuff. Does it connect the data to the claim? So we're going to look at the data. Is the data connected to the claim? And when you state it, you got to show that connection. And then we're also going to connect the data or claim to a scientific principle. So we could say we measured this and it connects to our hypothesis, and it also connects to the scientific principle of conservation of energy, or connects to the scientific principle of gravity. So, and we'll get there. So, but we're going to be looking for those two pieces. Now, there is a couple of key words for a pendulum. A pendulum is any object so this is an object on a string, and I can grab it and pull it back, and I let it go, and it swings back and forth. So I could let's see if I have a pendulum in my pocket. So we can imagine this is a car key. If it swings back and forth, that is a pendulum, okay? Now this one is a perfect string, a single piece of string with a weight at the end, and we're just swinging it. It's just swinging back and forth, okay? That is a pendulum. Now, the great thing with the computer simulation is there's no friction and it keeps swinging without stopping. It's amazing. So that's our simulation. So we are going to be deciding an input. So we're going to be messing with different inputs for the pendulum and then see what the result is and how it affects the period. That's actually what we're going to be looking at. So the period of a pendulum is the time of one oscillation. So if I turn on the stopwatch here, so if it gets up here, that's where we're going to start. So it goes here. So if we start here, and there's one swing. So one cycle. Okay, that's a period. And we're going to measure that. So I'm going to let it swing and go. Okay, no, I didn't stop it. Here, let's reset, and go. Stop. So it has a period of about 1.56 seconds. That's how we're going to read that. Okay. So that's going to drive me nuts. Pause. Okay. So some controls are some things that we want to keep the same so that we can be sure that what we put in is actually what's causing the result. If you put two inputs, well, which one is the one causing the dependent variable to have the result it's having? Okay. So we're on the simulation. We're on the intro version of the simulation. We've got the stopwatch turned on. So right here, click on the stopwatch in the window. So we got the stopwatch up. Looking at the controls, there are a few independent variables that might affect the time for a pendulum to oscillate. The dependent variable, let's see, I think my word's cut off. The dependent variable, the independent variables could be length. So the length of the string could be one variable. The mass, how large this weight is. Gravity, what type of gravity? Are we on the Earth? Are we on the moon where gravity is different? And the release angle. So I've got it released here. I could actually take it and release it from a higher angle. So we're looking at, will it let me change? So we're looking at length of string. We're going to be looking at mass. We're going to be looking at gravity. And we're going to pick the Earth to start with. We can look at friction. What are some things that affect how this pendulum swings? Okay. So here's the question for the day. This is the most important part. Which independent variable, length, mass, gravity, or release angle affects the time for the pendulum to oscillate the most? That's the question we're going to answer today. Okay? And I don't want you to try to get ahead of me. I want you to kind of follow along because it'll help a lot of things make sense as we go. So length, mass, gravity, or release angle. And we're going to try all of these, but we're going to start with mass. Okay? So write your hypothesis for mass. As the blank increases, the dV will change in a measured way. Okay? So in this case, what's the independent variable? What are we inputting and what are we changing? To start with, we are changing the mass. So as the mass increases, the time for the pendulum to oscillate 10 times will, if I let this oscillate 10 times, okay? If I let this oscillate 10 times, it'll just give us a better chance to get an accurate time, okay? So as the mass gets bigger, will the pendulum oscillate at a faster rate? Will it swing faster? Will it swing slower? What's gonna happen to the time? Now this is a tricky question because the time, if it swings faster, will the time be bigger or smaller? Okay. So if I swing fast, time's going to be small. Okay. If I swing slow, the time it takes for it to swing 10 times, it's going to take longer. So the time is going to be bigger. Okay. So that's my educated guess anyway. So hypothesis, go ahead and finish writing this hypothesis. We actually did the first part for you. So go ahead and finish that off. As the mass increases, the time for the pendulum to oscillate 10 times will increase, decrease, or stay the same. What do you think? Okay. If you need to pause the video and write it, please do so. Okay, so now we're going to design the experiment. Well, guess what? I was nice and I went ahead and designed the experiment for you just so we could talk about it. So the input is going to be mass. We're going to change the mass over here. So we're going to change the size of this mass. We're going to change the mass, okay? And as the mass gets bigger, so as I go from, we're going to start with a small mass, and it's going to get bigger. What's going to happen to the rate of the swing? Is it going to get faster? Is it going to get slower? Or is it going to remain the constant or stay the same? So if that's what we're inputting, what has to stay the same? What has to be controlled? Well, the release angle. If I change the release angle, let's say I put it at 40 degrees. Do I want to do the next swing at something else? I'm going to try it again and I'm going to set it at no, because then I have two inputs. I've input a change in the mass and I've input a change in the angle. I don't know which one's causing the effect that we're looking at, okay? So we're going to use a release angle of, what does it say? 30 degrees. So we're actually going to set this to 30 degrees. So set it to 30 degrees. Okay, 30 degrees. Length, keep the pendulum at 0.8. So we're going to put the pendulum at 0.8 meters. Gravity, we're going to keep on the earth. So gravity is right here. We're going to keep it on the earth. And friction, we're going to keep it on none. So that should be, make sure that's set to none. And then we're going to, for our output, we're going to calculate the time. So we're going to need to hit reset on the timer. Make sure you got the stopwatch set. Okay. And we're going to hit play, and then we're going to watch it swing. And then we're going to, once it gets to a starting point, we're going to start the timer and then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 swings and stop. Stop the stopwatch. Just let it keep swinging, but stop the stopwatch, okay? Once you stop this timer, we're going to write it down. Now, you're probably going to mess this up the first time, and you're going to have to do it over. It's okay. So if you're doing this and you hit play, and then you hit the timer, and now you mess it up, oops, okay, guess what? The timer stops with you when you pause the simulation, okay? But if you do mess up, you can do two things. You can hit reset, but make sure that you go back and reset all the parameters, okay? And click the stopwatch, and then go back to 30 for your starting point. Oops. So let's pause. Let's get this to 30. Okay. Okay. So now our experiment's set up, except for we're going to control the mass. We're going to start, our mass is our input. So we're going to start with a mass of, not length, a mass of 0.3 kilograms. 0.3 kilograms, kilo means 1,000. 0.3, so it's 1,000 grams. Pull the pendulum back to, that says 20 degrees. We're going to keep it at 30 degrees, okay? Yeah, let's change that back to 30. Okay, so we're going to do this for each one. So here we go. Ready, and play, play. And when it gets back to the starting, start. 2, 3, 4, 5, 6, 7, 8, 9, 10, and stop. 18.15 seconds. So in this box, I'm going to write 18.15 seconds. Okay? And then I'm going to pause or hit reset. Make sure this is set to 0.8. This is set to the next one, which is 0.6, right? 0.6. Okay? Gravity's on Earth, no friction. And take this to 30 degrees. 30 degrees. And let it start swinging. All my parameters are set, and turn on my stopwatch, and ready, set, and go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, stop. 18.12 seconds. Okay, so you're going to repeat that for all of these masses. Okay, so go ahead and do that for me. Pause the video, and go ahead and do that for me. All right, so welcome back. So now we're going to look at the analysis. I'm actually going to make this a little bit larger so we can look at this. So look at the times in the table. Not what you think they should have been, but look at the actual times. What do you got? Okay. Yeah, there's probably some error in this experiment. Okay. But look at those numbers and tell me, you're going to answer some questions and tell me, what do these numbers actually mean? So do number 1, go back to the simulation, try the timer, just see how fast you can start and stop it. So let it start. You may have to let the pendulum swing. So See how fast you can start and stop it? That's called reaction time. And write that down here. So now number 2, time for 10 oscillations. You can highlight by going up here to the highlighter, picking your color, and you can highlight the one that is most correct. And you'll see what you get. I know what the answer is supposed to be. Hint, hint. Letter G looks pretty good. Does that make sense? Am I wrong? Be careful, I'm a pretty tricky person. So is it that answer? Okay. Why did you choose the answer that you did choose? Tell me. Write a sentence, a complete sentence. I chose letter A because the numbers did this. I chose letter B because, I chose letter G because maybe there was a slight change in the numbers, but it was very small. Or I chose B because it kind of went larger, okay? Why did you choose it? Number 4, did your results agree with your hypothesis? Yes, no? So my results disagreed with my hypothesis because I said it would increase and it decreased, or I said it would decrease and it stayed the same. What did you say? Tell me. Complete sentence right here. Okay, so number 5, after looking at that, what does that mean? Does mass have an effect on the time of the oscillation of a period? Does mass matter? Well, there's a pun there. You know your definition of mass. Okay. So answer this question for me, please. Can someone repeat your experiment and get the same results? Okay, at this point, you probably need to take maybe a small break. So pause the video, stand up, shake everything out, take a quick break. So I'm actually gonna do that myself. Stretch to the sky. Oh. And back down. Okay, welcome back. So now we're going to test one of our other independent variables. We're going to test release angle. So as you can see, now we're going to do release angle. We're going to release this at different angles. So we're going to release it at different angles. But before we do that, I want you to write in a hypothesis. What do you think? What do you think is going to happen? As the release angle gets bigger, as the release angle increases, the time for 10 swings, is it going to get smaller? Is it going to get bigger? Is it going to stay the same? Follow these settings just like before. Follow these settings. Okay, and what angle? Okay. Yeah, follow these settings. These are negative angles. So negative means direction. So look at this, watch this, there's -10. So you can do it there, that's where we're starting, okay? All right, so pause the video and get those numbers recorded for your 10 oscillations. Make sure you have all these settings set properly. Welcome back. Let's analyze our information. What's our reaction time like? Go look at what you did above and now answer this question. What happened? Look at the data, not what you thought. Look at the actual numbers you got. Okay, and which one of these is true? Then number 8, you're going to tell me why. And number 9, did that match your hypothesis? Okay. What can you conclude about the release angle's effect on the time of the oscillation? You should consider these things. My times didn't match, or this was happening, okay? Whatever that might be. So pretty much the rest of the lab is the same for the two other different parameters. So you need to continue trying that. You're going to try it on different planets and see what happens. Okay, and then you're going to answer some questions. So, and then when you get to the end, we're going to have a big overall thing. What were we investigating overall? How does it, what actually has the biggest effect? What had zero effect? What had some effect? What are the problems we ran into? You're going to basically summarize everything that you just did here. Okay? So that's all I've got for now. Enjoy your Pendulum Lab, and I hope you also get to see that sometimes it's not as cut and dry as you would like to think it is. So follow the data, and it will not lead you astray. Okay, so once you finish all that, make sure that you are also studying for your quiz tomorrow. I will open it up on Friday, and you'll have your 3 attempts in work. Please drop me an email if you have any questions or problems. And that's all I've got. Have a great day. Have a great weekend. And we'll see you next week.